In this lecture, we're going to learn about the new keywords introduced in C++20 to allow us to pause and resume our coroutines. And they are what you see here. We have coyield, which is going to suspend our coroutine and return a value that we can use in our C++ program. We have coreturn, which is going to complete execution of our coroutine and optionally return a value. So this is really going to be a return statement from a function, but it is going to be different in a way in that it is going to pause our coroutine. We also have coawait, which is going to suspend execution and wait for something to happen in our C++ program. And then we're going to have the ability to resume this coroutine. So we can use these three keywords here to pause our coroutine and have the ability to resume it, at least with coyield and coawait, because coreturn is really going to finish execution of our coroutine. Now, if a function has one of these keywords, it is going to become a coroutine. There is no other mechanism to make a function a coroutine. So if you have any of these keywords here, your function is going to become a coroutine implicitly in C++20. Now, it's not every function in C++ that can be a coroutine. There are some exceptions. For example, const_expr functions can't be coroutines. You can't have a coroutine constructor. You can't have a destructor be a coroutine. And the main function can't be a coroutine. And these are restrictions that are in place you need to be aware of. Now, if you try and put a coroutine keyword in any of these functions, you're going to get a bunch of compiler errors, and you should know that you have done something wrong by then. Now, let's look at a few examples of how we can use these keywords. Here we're going to look at coyield, and we have seen that coyield is going to pause execution and return a value. Here we have func1, which has a bunch of coyield statements inside. So when you call this function like we do in the main function here, you are going to start executing it. And when you hit the first statement here, we are going to pause execution. So the state of this function is going to be stored somewhere on the heap. We are going to store the parameters. We are going to store the local variables, and we are going to store the resumption point where we're going to start execution when this guy is resumed. And we don't want to forget the coroutine handle that we're going to use to resume this function if we happen to need that. This is really important to remember. So we're going to pause and return this 45, and we can use it if we need that in our C++ program. Now, this coroutine here is going to be set up in a way that we can call it as a function. So for example, if we call f1 here, we'll get our 45 printed out as a result of the pausing that we did. So we'll stop and yield a value that we can use later in our C++ program. Now, I realize this can really be confusing. This is counterintuitive if you know regular C++, but bear with me. I am giving you this information in little pieces so that you can digest this, and I am confident that by the end of the chapter, you will really understand how all of this is really coming together. So coyield is going to pause execution and return a value that you can use later in your C++ program, and we can see that right here. So every time we call f1, this is going to resume execution, and we're going to hit the next point. If we call f1 again, we're going to print 46. You can see that right here. If we call f1 again, we're going to run all the way to this pause point here. We're going to pause, and if we resume, we're going to get a 47 here. And the next time we call, we're going to call return. So we're going to return from this function here. And this is going to be the end of our coroutine. So by the point we print 48 here, we have really ended our coroutine, and we have no business calling it again. If we do that, we will get undefined behavior. You should be aware of this. So again, calling f1 is going to resume execution. The first time we're going to run until we hit the 45 here. So we're going to coyield and pause. We're going to return the 45. That's what we see right here. Next time we call f1, we will run until we hit coyield 46. We're going to return this and print that out. That's what you see right here. Next time we call f1, we're going to resume from this point, and we're going to run until we hit coyield 47. This is going to return 47 that we print right here. And next time we resume by calling f1, we will run until the call return statement. We're going to return 45. We're going to print that that right here. And that will be the end of our coroutine. If we try to resume again like we do on this line here, this is going to be undefined behavior because we want to resume a coroutine that has really ended execution, and that's going to be really bad. You may get a value, you may get a junk value, you may get a crash. So this is bad. You should never try to resume a coroutine that has run to completion. If you do that, you will be setting yourself for disaster. Just be aware of this. So this is how we can use the co-yield operator we have in C++20. It is going to post execution again, and it is going to return a value that we can use in our C++ program like we are doing in the main function here. Here is another example of how we can use co-yield. It is really the same version. We are just putting our co-yield statement in a loop, which is going to run forever. So we will be looping forever, returning a value through this co-yield operator. We're going to start from 1 and we will keep incrementing. And note that the moment you set up a coroutine and call it like this, it is going to pause by default. So suppose that we call func2 here, it is going to go all the way to here, but it's not going to execute any statement in the body of the coroutine first. So it is going to freeze at this point. If we call it for the first time, it is going to initialize the int start value here, and it is going to run the loop for the first time. It is going to co-yield, so it is going to give us a 1 that we're going to print, and then it is going to increment later. Next time we resume this, it is going to print a 2, and it is going to keep incrementing as we call it in our loop here. Hopefully this is making some sense. So if we run this program, we will print values from 1 all the way to 10 because the loop is going to run 10 times here. Hopefully this is making sense. And if it isn't, please bear with me. We're going to have a chance to run code like this and you will see how all this comes together because coroutines can really be confusing. I myself had to look at this maybe for a week or more to actually have an idea of how all this comes together. Now we have seen the co-yield operator. Now we're going to look at co-return. Co-return is going to be a little bit easy. It is going to end execution of a function or a coroutine, I should say, and it is optionally going to return a value. In this case, it is going to return a 45. If we call our coroutine like this, so this is going to print 55, and our coroutine is going to run to completion because this is the only statement in here. So if we try to resume this coroutine by calling F3 again here, this is going to blow up because we are trying to resume a coroutine that has already run to completion. This is what you can do with the co-return operator. Please note that it is possible to not put an operand on this co-return operator, and the coroutine is just going to end and not give you a return value that you can then use in your C++ program. And you can set up code like this if it makes sense for whatever you are doing with C++. We also have the co-await operator. The co-await operator is going to pause execution, and the information about our function is going to be stored somewhere on the heap. Again, we will store, for example, the parameters, the local variables, and the return point where we're going to start executing if this guy is resumed. Don't forget to have your coroutine handle because this is going to be your only contact point with this information you have on the heap. So we will go through this handle to resume computation. So in this case, if we create an object of this coroutine here as we do in the main function, our function is going to run and pause for the first time. So we will hit this point here and freeze. If we resume our task somehow, this is going to run until we hit another suspension point. So this is going to run up until this point. We're going to pause and we're going to store information about this coroutine on the heap again. So we will have our coroutine handle that we're going to use to resume. If we resume again, we will run until we hit this suspension point. We will pause again and we will store information about our coroutine in our coroutine frame as we see right here. And we will have our coroutine handle we can use to resume. We will try to resume this function using our coroutine again, and our code is going to run to completion as a result of this resuming we do here. Now, if we try to resume again from this point, please remember that we have run to completion If we try to resume again, this is going to be a disaster because we are trying to resume something that has already run to completion. And this is how you can use the co-await operator. Notice that I am ignoring the suspend always we have here. Now we don't have enough tools to really understand this, but just understand what these operators do. We have three operators. We have co-yield, which is going to pose and return a value. We have co-return, which is going to end execution of a function and return a value optionally. And we have co-await, which is going to pose execution and not return anything. It is just going to suspend execution, and we will await for something to happen. And when that thing happens, we will resume execution. And a good use of this is, for example, if you are writing networking code. Suppose you are downloading something from the internet, and in your code, you have to wait for those things to come. When you have all the data, you can resume execution and you can use that data. And that's a really good use case for the co-await operator. Now, we have seen a lot of code about these operators, but you must be asking, how do we actually run code like this? And I hate to break it to you, in C++20, we don't have coroutine types we can use to run code like we have seen using the coroutine operators we have learned about. And those are co-return, co-await, and co-yield. You can't really use them as of yet. To be able to use them, you have to set up a coroutine infrastructure that is going to support the posing and resuming features that we want in our functions. And in C++20, we only have this coroutine infrastructure to build coroutine types. And we will show you a way you can build your own coroutine types using this infrastructure. But before we do that, we need to look at this infrastructure and make you aware of it. And that's going to give us the ability to build our own coroutine types that we can use to see all this posing and resuming happening. So we are going to pause here in this lecture. In the next one, we will zoom in and look at what this infrastructure is all about. So go ahead and finish up here and meet me there.